Well, hey everyone. We have a special guest today from Magicleap. Lin Sun is here. We have seen all the awesome demos of Magicleap and how the immersive metaverse you can create with the glasses itself. We'll be curious before we get into, can you give us a brief background about yourself and how do you get where you are now?
Yeah, sure. Thank you for inviting me here, and it's my pleasure to be here. And it's very good conference and good talk with you. And I think, yeah, for me, previously I'm working at Samsung, leading the perception team there, working on the self-driving car, and then I joined Magicleap as a director leading the AI teams here. We are working on different things, and you can imagine that the perception system for the metaverse is very complicated, and so I'm leading the AI part, working on the hand tracking stuffs and the word understanding stuffs, and also the reconstruction and also understanding the word. And also we are working on some the vision language model, large language model, multimodality stuffs, and particularly for the digital twin building and also understanding the environment around you.
Lin, you have been in this field way above everyone. So before even AI, second hype, third hype, whatever, from 2012. But before that, you were doing research in video compression. And if you recently saw the interview with Ilya Sutskever, it's like he was telling that the prediction of the next token is actually compressing the world knowledge into these language models. Can you tell us, what are the insights that you have learned from video compression that are actually applied now in the visual language models?
Oh, it's a very interesting topic. Yes, you are right. And I'm working on the video compression before. And so that's why my PhD topic is related how to apply the AI to the video, to do the video understanding, to do the action recognition. And for now, as you know that we are working on a lot of things. That is a large language model, and definitely is a popular one and dominant this AI area. And for the large language model, for the transformers, the important thing is to predict the next token. And for AI, for the video compression, the similar things, that is you need to predict or compress the frames and predict the next frame. And so this is also the core part for the compression. But compression, it's very structured. That is the video compression. You have the blocks, and you encode in the blocks and do the motion vector prediction and the motion prediction and generate the motion vector and then predict the next frame. But for the large language model, I think, yeah, it's still. Even we try to explain a lot of things, but still it's a black box, and we have self-attention, cross-attention, and generate the next token, and from a large amount of the data. And so that's I think the big difference. And but this is why I transfer from the video compression area to the AI area, because I think AI area has a lot of mystery that we cannot explain, and we didn't know. So that's why we need a lot of AI experts to push forward this area and to know more about AI, how to control AI, harness the data, harness the AI models, and to serve the best purpose.
There was a recent paper that was published by enthusiasts, taking the vector search, and instead of doing a vector search using embedding models, they use gzip, just the compression of the unstructured data, and then got good enough accuracy with the naive compression techniques that we have. So my question is to you, let's say you take all the videos that are available in the world that we've captured so far, and you compress this data. Do you believe that there is actually the intelligence that will get out of it, or you need to actually apply some as you mentioned about different transformers, algorithmic efficiencies to actually structure the way the compression is done so you can capture the more causal understanding of how the world works?
Yeah, this is a very good question, and I should say that that a lot of we currently a lot of companies try to handle the text data, and also we have a lot of text data, image data, but I think the future is video data, and because video, it's too large and need a lot of storage, and it's very difficult to understanding, and also it's long and long sequence, and so I think for the tech company definitely it's a good time to think about how to compress the video and how to extract the useful information from the video, and I think a lot of try in this area, and such as of course a lot of a lot of people try to do the multi frames and to understand the video or 3D reconstruction or 3D geometry information from these multi frames. But what's a good or information for the video understanding, I think is still unknown. And but you know that when you handle the videos, it has a lot of redundancy. And so this is why for video compression is working and for the videos, because we have a lot of redundancy, and so we can explore this redundancy to really understand the video, compress the video, and to a smaller size, and even 20 times smaller than the original video, or several hundreds times smaller than the original video. I think for the AI now, I think the important thing is that how to structure the video data, how to store the video data in the storage, and can be efficiently searched, and can be efficiently stored and restored. And after you want to get this video reconstructed. And so a lot of interesting topic, and I still think that video is an unexplored area, and this is why it's my PhD topic.
Totally.
I know that a lot of people now understand the importance of the video, and you know that the interesting thing is that it's you know that the images and the text, we can quickly get a bunch of the data and label the data, but not for videos. And so I think for me and for other researchers, definitely this is a very hot area, very useful area, and for the future, or even has a high impact for our daily life. Yeah.
Tell us more about Magic Leap. What's happening? What are you working on? What are the next exciting things that you're going to publish, especially in multimodality and videos, and what are the challenges you face there?
Yeah, actually, you know, Magic Leap is already long stand in this field and many years, and we are the first company proposing the AR stuffs and how to build this AR devices and to really augment the visual content in front of you. And so we have developed a lot of tag, and including the basic, the head pose, eye tracking, hand tracking, word understanding, and the reconstruction, digital twin, and this kind of things. And so, for me, actually, I did a lot of the AI stuffs, and such as I mentioned that on the ML2, actually, the hand tracking is directly delivered from my side, and when I joined the team and supervise this team and deliver this hand tracking. Hand tracking is a very important input for the users to interact with the virtual and the real object. And currently, I think we are working on a lot of cool stuff. That is, I think, for me, a lot of memory stuff, the recording stuff, such as a document, and such as the cloud-based, the image, and the photo cloud. But it never has a visual memory for us, and so I hope that we can really record our memory and in the visual stuff. And so anytime you want to find some stuff, such as a key, always I miss the key. I try to find it, and so you can really just recall, use your device and tell you where is your key. And so that's why we try to digitalize the world and understanding the world, and then interact with the world. So this is something we are working on. And of course, this is very challenging. And you know, recently the Meta in the connector, they released a hyperspace. It's a high photorealistic reconstruction of digital twin. But how to interact with this the environment and how to understand the environment. This is something, in the next step, also something we are working on. Yeah.
Nice. Those are very top topics today. As you have seen, a lot of portable devices that come out and say, "Hey, I'll be your friend. We'll take over that."
Yeah.
Sorry, but what is the key challenge? We have seen also like a lot of failed product launches that promise all this, like, "Hey, we'll accompany you and recall everything." What are the yet not unsolved challenges that still need to be addressed to make this use case super successful on a consumer level?
You mean the
The retrieval you mentioned, what are the challenges for managing the data, on the searching the data over and bringing back into the context of the language models?
Yeah, a lot of challenges, and the first and the important thing is data. Yeah, data availability and also data quality, and this is something I think all the industry, all the companies are facing. And the first things they should consider, and the second thing is I think is about compliance and rules and privacy or security, this kind of things. And so I think this is why I think a lot of particularly in US, I think the privacy is a very concerned thing, and whatever the smart glass or other devices release, and the first things we consider that whether it break our privacy and whether it has some sensitive data streaming to the cloud and this kind of things. And so this is definitely something challenging. It's very challenging, and also I'm not sure how to really resolve this kind of problem. And another thing I think is there's a current infrastructure or framework, and how to balance on-device data and offload data, and so how to particularly your personal information, and how to give you the personalized advice on the device, not offload to the cloud. So a lot of things and a lot of challenges in this area, and I think also the tech is also not ready, I should say. and we are still working on the tech, how to make it reliable, how to make it really vivid and useful for your daily life, and make your life easier, not harder.
You have been in this field for more than 12 years, from the early days of AlexNet, and you're still excited. What keeps you excited about this field, and how do you see this evolving in the next 5 years?
Yeah, that's a good question. Actually, I'm so excited. I'm still have a lot of passion because as I mentioned, that AI still has a lot of mystery. I want to explore. Also, AI is advancing so fast. You know that previously we are working on the convolutional neural network, and we try to use even some autoencoder. And now you know that we just use a transformer, a lot of transformers, and also hybrid models, and and even more the models in this area. And so it's advancing so fast and so fascinated, and so you never know what's the next thing. And but for me, I think the some things I'm very interested in is in the future is that how to work with AI or AI work with human. That is always some researcher will debate that maybe AI will destroy the human being, or we should have the regulation on the AI. I think, but in my opinion, that how to co-create the future life with AI and the human definitely is a future. And also now we have already did a lot of this kind of stuff, such as everyone uses ChatGPT or similar stuff, product, and but actually after you get a suggestion from the ChatGPT, actually as a human you need to think about that what's your answer, and based on this answer how to combine your thoughts inside, and so this is very important. And also that at Stanford we already know that in the near future we will have millions of machine learning engineers. But at Stanford, we want to push us to be a good, high quality researchers, actually push this area. And this is very important. I think whatever AI involved, and you need to consider that you have the knowledge to control it. You have this knowledge to understand how AI works. And also you combine your knowledge with AI to make your life better. And so this is something I think in my mind about the AI stuff and also the future. Yeah.
Totally agree, Lin. Great to have a conversation with you. Thanks for taking the time and enjoy the conference.
Yeah. Thank you. Thank you.